Okay, Algebra 2 friends, today you're going to learn about section 8.6, which is some theorems that you have to know. You will need to know this information for your quiz next week, so please make sure you do the notes. I guess let's just start an example. Example number 1. What are the possible rational roots of 2x cubed minus x squared plus 2x plus 5 equal to 0? So this polynomial has 3 roots because it's a cubic. The possible rational roots have, it's called the rational root theorem, but here it is. This polynomial only has possible rational roots that have this form here. You would take the factors of the constant term, which the constant term is 5, and you would divide it by the factors of the leading coefficient, which the leading coefficient here is 2. And then that would give you the possible rational roots for example 1. So let's try it. You take the factors of the constant, which is 5, so the factors are plus or minus 1 and plus or minus 5. Those are the factors of positive 5. And now you do the factors of the leading coefficient, which in this case it is 2. So the factors of 2 would be plus or minus 1 and plus or minus 2, because negative 1 times negative 2 can give you a positive 2. And then the possible rational roots for this example, based on the rational root theorem, you're going to take the factors of the constant, so 1 and 5, and you're going to divide them by the factors of the leading coefficient. So that means you take plus or minus 1 and plus or minus 5, and you will divide it by 1. So that's how I got this plus minus 1 plus minus 5. And then you do it again. You take the factors of the constant, so the plus minus 1 plus minus 5, and now you divide by the other factors of the leading coefficient, so you divide by 2. So therefore you'll end up with plus minus 1 over 2 and plus minus 5 over 2. So those are the only possible rational roots of this cubic. So they're right here. All right, so now let's actually try an example together here. Example 2. What are the possible rational roots of this other cubic here? So again, what we're going to do is we're going to list the factors of the constant. So that's just going to be like 1 and 2. And technically that should be like plus or minus. And now we're going to list the factors of the leading coefficient. So 15. That's going to have a lot of factors. It's going to be 1, 3, 5, and 15. And let's just put them in a little bracket with plus or minus. All right, so now for your answer, which are the possible rational roots. Possible rational roots. So if you ever see me using PRR, that stands for possible rational roots. So the possible rational roots are going to be, you need to take the factors of the constant, so 1 and 2, and you need to divide them by all of the factors of the leading coefficient. So that means I'm going to take 1 and 2, and I'm going to divide them by 1. So that's just going to give me 1 and 2. Then I'm going to take 1 and 2, and I'm going to divide them by 3. So that's going to give me a 1/3 and a 2/3. Next, I'm going to take 1 and 2 and divide them by 5. So 1/5, 2/5. And finally, I'm going to take the factors of the constant one last time, so 1 and 2, and divide them by the last factor of the leading coefficient, so 15. 1/15 and 2/15. And now those should all be plus minus. So we're just going to put a little plus minus in front of all that. So that's how you find the possible rational roots. You need to list the factors of the constant, and then you need to divide those by all of the factors of the leading coefficient. And then don't forget that this should be the positives and the negatives, so you just put a plus or minus in front of all of them. And that's called the rational root theorem. You need to know how to do that. And now the reason why we need the rational root theorem is to actually find the real roots, the actual roots of a polynomial. So for example, example 3. Now I need you to find the actual roots of this polynomial. So again, this polynomial is a cubic, so it has 3 roots. And the 3 roots that it has should be one of these possible, that should come from this list of possible rational roots. So the bad news here is that what you're going to have to do is you're going to have to take this cubic polynomial and start guessing and checking until you find at least one root. And you'll do that by synthetic division. And remember that if you synthetically divide a polynomial by a factor, if the remainder is 0, that means that that is a root of the polynomial. So that's what we're about to do. So let's try it. Okay, so let's find one of the roots of this cubic by starting to synthetically divide this polynomial by the list of possible rational roots. So, step 1, find the list of possible rational roots. Well, I already did that on example 2, so done. Now we're going to take this polynomial and start like literally guessing and checking. Okay, always start with like 1. So I'm going to synthetically divide this polynomial by 1 to see if 1 is a root. So put the 1 in the box and now copy the coefficients of the polynomial. So 15, negative 32, 3, and 2. So let's go ahead and synthetically divide the polynomial by 1. If 1 is a root, the remainder will be 0. So let's see if that works. 15 times 1 is 15. And remember that you're adding here. When you add 15 plus negative 32, that gives you negative 17. Negative 17 times 1 is negative 17. When you add it to 3, that gives you negative 14. Negative 14 times 1 is negative 14. And then when you add it to 2, that gives you a negative 12. Okay, so this is the remainder. Since it is not equal to 0, that means that 1 is not a root. So 1 is not a root of the polynomial. So now we just have to keep trying and keep guessing until we do find a root. So until we do get a remainder of 0. So what I do, I start with the smallest numbers, 1. And then now try negative 1, because sometimes that will work. So let's try negative 1 and see if this works. So let's divide the polynomial, 15, negative 32, 3, and 2. Let's go ahead and synthetically divide it by negative 1 this time and see if negative 1 is a root. So I'm going to be adding here. 15 times negative 1 is negative 15. And then if I add that, that's negative 47. I don't think this is going to be right. Negative 47 times negative 1 is positive 47. If I add that, that's going to be 50. Yeah, no, that just keeps getting bigger. 15 times negative 1 is negative 50. If I add that, that's a negative 48. Okay, so the remainder wasn't 0. So bad news is that negative 1 is not a root either. Okay, so don't give up. You need to do it. So let's move on to 2. Let's synthetically divide the polynomial by 2, and hopefully 2 is a root. If not, we'll try negative 2. And if not, we'll try the fractions. So let's start with 2. Let's divide, so put 2 in the box and divide the polynomial by 2. 15, negative 32, 3, and 2. Bring that down. So 15 times 2 is 30. 30 plus negative 32 is negative 2. Negative 2 times 2 is negative 4. Negative 4 plus 3 is negative 1. This is looking promising. Negative 1 times 2 is negative 2. And negative 2 plus 2 is 0. Finally. Yay. Okay. So the remainder here is 0. So that means that 2 is a root. So 2 is a root of the polynomial. So that's one of your answers. Okay. So now we need to find, there should be 3 roots because it is a cubic. But what we're going to do, in order to find the other 2 roots, let's not let's not waste time guessing, and like we're not going to keep guessing anymore, because now here's the good news. Not that you found one of the roots, so 2. What you can do is you can take this reduced answer and write this polynomial here. So remember that when you do synthetic division, these are the coefficients of your answer. So this would be a 15. This time it would be an x squared because it's 1 degree less than what you started with, minus 2x plus 1. So now I just need to find the roots of this quadratic to find the other 2 roots that are left over. So again, instead of doing the synthetic division and guessing and checking, I'm just either going to factor this quadratic, or maybe use the quadratic formula, whatever's easiest or whatever's fastest for you. I'm going to try to factor it just because I know it factors. But if it doesn't factor, we could use the quadratic formula. Okay, so to give me a 15x squared, I think it's going to be 5x and 3x. To give me a 1, well, there's only one way, which is 1. 1. And what did I do? Oh, that should be a minus 1 right here. Okay, that's a minus 1. So one of these needs to be positive, and one needs to be negative. This is going to work since negative 1 times positive 1 is negative 1. And then if you FOIL this correctly, like this, 1 times 3x is 3x. 5x times a negative 1 is negative 5x. And if you add those together, that gives you a negative 2x. So now I know that I factored it right. And again, if you don't like to factor, you could just use the quadratic formula and try to solve by using quadratic formula. So now that it is factored, I can find the other 2 roots. So 5x plus 1 is a factor, so that means that negative 1 over 5 is a root, because you would just set 5x plus 1 equals to 0 and solve. And then the other one, 3x minus 1 equals to 0, that means that 1/3 is the root. So these are roots. So to finish example 3, where it says find the roots, so the actual roots are the 2 that we found originally, the negative 1/5, and the 1/3 that I found by factoring. So that is how you find roots of a polynomial by hand. And now we need to try it again on example 4. Okay, so example 4 is going to be the same thing, except for it's harder because example 4 is a quartic. It has 2x to the 4th. So that means there are 4 roots. So again, in order for you to find the root, you're going to have to start guessing and checking. And before you start guessing and checking, you need to make a list of the possibilities, like the possible rational roots. Because if you don't make a list of the possibilities, then you're going to have like an infinite number of guesses here. So example 4, to find the roots, let's first make the list of the possible rational roots, like we did on example 2. And remember, in order to do that, you take the factors of the constant. So my constant is 10. The factors here would be 1, 2, 5, and 10. So let me put those in a little plus or minus bracket. And now we need to take all of those factors and divide them by the factors of the leading coefficient. So the leading coefficient is 2. The factors of that would be 1 and 2. So now to make my possible rational root list, we are going to take the factors of the constant and divide them by all of the factors of the leading coefficient. So let's take 1, 2, 5, and 10 and divide them by 1. Well, that's going to be easy. That's going to be 1, 2, 5, and 10. Okay, now let's take 1, 2, 5, and 10 and divide them by 2. So 1 divided by 2 is 1/2. 2 divided by 2 is just 1, but we don't need to write 1 again because I already have it here. 5 divided by 2 is 5/2. 10 divided by 2 is 5. So we don't need to write 5 because I already have it there. And then that's it. So this is the list. Don't forget to put the little plus or minus in front. Okay, so now that's a little better because instead of guessing from like an infinite number of possibilities, to find the roots here, we're only going to guess and check these numbers to see which ones of these are roots. Okay, so let's just start. I always start with 1 and then try -1 and then move on to 2 and try -2 and then just keep going. So let's start with 1. Let's go ahead and put 1 in the box and synthetically divide my quartic by 1. So that's a 2, -4. Let me wake up the computer. Okay, there we go. So 2, -4, 8, 4, -10. That's going to be synthetically divided by 1. So bring the 2 down. And now let's start multiplying and adding. 2 times 1 is 2. Plus -4 is -2. -2 times 1 is -2. Plus 8 is 6. 6 times 1 is 6. Plus 4 is 10. This is looking good because 10 times 1 is 10. Plus -10 is 0. Yay. Okay, so great news. We have found one of the roots. So 1 is a root. And now 1 is a root, but remember there should be 4 roots since this is a quartic. And what we're going to do now, every time you find a root, always rewrite the reduced polynomial. So what I mean by that is, now that I know 1 is a root, let me take my answer here, which is 2x to the 3rd now, because when you synthetically divide, you bring the exponent down 1 by 1. So it used to be a quartic, but now it's a cubic because I took out one of the roots. Minus 2x squared plus 6x plus 10. All right, so now I have this cubic, which is kind of what I started with on example 3. Now I have this cubic and I need to find the 3 roots. And again, since it's not a quadratic, you can't just factor it. You're going to have to guess and check again. So we will have to guess and check by synthetically dividing by the possible rational roots into this polynomial. And okay, one thing we can do for sure here, well, let's just leave it like that. I was going to divide it by 2, but let's just leave it like that. Okay, so let's go ahead and take this cubic and continue dividing by the possible rational roots. So technically we're supposed to divide by 1 again to see if 1 is a double root. So let's do that again. So let's take the new cubic and divide it by 1 again. So 2, -2, 6, 10. You want to divide by 1 again because sometimes your root is what's called a double root. So the factor would have been like x minus 1 squared. So you want to divide by 1 again and see if it's a double root. So then start synthetically dividing. 2 times 1 is 2. That's 0. And 0 times 1 is 0. That's 6. Okay, so this is not going to be a root again. Okay, so this 1 is not a root again of the cubic. So that means that 1 is not a double root. So 1 is still a root because it was a root of the quartic. So 1 is a root. But 1 is not a double root. Not a double root. Okay, so now we need to go ahead and try to find another root. So I already tried 1, that didn't work. Let's try -1. -1. And again, you want to try it on the reduced cubic. Don't try -1 on the quartic again because then you're not going to get anywhere. Let's try it on the reduced cubic. So let's take -1, put it in the box, and let's divide this cubic by -1. So 2, -2, 6, and 10. So we're going to multiply and add. 2 times -1 is -2. So that gives me -4. -4 times -1 is +4. 4 plus 6 is 10. That one's looking good because 10 times negative 1 is negative 10. And then when you add that, you have another root. So negative 1 is a root. Negative 1 is a root. And again, if you do it in the correct steps, like once you find one root of the quartic, make sure now you're working with the cubic. And now that you found a root of the cubic, you should now be working with the reduced quadratic. So in the reduced quadratic is what was left over here. So my polynomial is now 2x squared minus 4x plus 10. So that's my reduced quadratic. And it has 2 roots, which are the missing 2 that I need for the 4 roots total. All right, so for that one, again, since it is a quadratic, you should just try to factor it or use a quadratic formula. For starters, let's go ahead and divide by 2 now, since all of these are divisible by 2. So 1x squared minus 2x plus 5. Let's see if we can factor that. 1x squared. Yeah, that ain't going to factor. So that's not going to factor. And just because it doesn't factor doesn't mean there isn't an answer. It just means we need to use the quadratic formula to get our answers. So let's go ahead and set that equal to 0 and use the quadratic formula. I'm going to use it right here. So x equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. So that's the quadratic formula. So x equals 2 plus or minus the square root. What's happening here? This is a 4 minus 20, negative 16. Okay, now that gives me 2 plus or minus. The square root of negative 16 would be 4i. So I can reduce this whole thing. So the remaining roots, so the roots of this quadratic are going to be 1 plus or minus 2i. So they happen to be imaginary. And so imaginary roots don't show up on your possible rational roots. These are only the real rational roots. So the final answer for example 4, I guess we can switch colors here. The actual roots are, they are 1, negative 1, and then 1 plus 2i and 1 minus 2i. So there's 4 separate roots. You can write 1 plus or minus 2i, that's fine. But that is how you use the possible rational roots in order for you to find the actual roots of a polynomial. And that's called 8.6. So now you need to practice. So go ahead and practice creating your possible rational roots. Go ahead and practice finding the actual roots by hand and synthetically divide until you get some roots. And every time you find a root, when you continue, make sure that you use the reduced polynomial. So here I use the cubic, and then once I find another root, I use the quadratic. So practice that. And now we need to go backwards. So on the next page, you need to write the polynomial given the roots. So I'm going to give you the roots, and now you need to give me the polynomial that would have those roots. So that's the next page. And it's another theorem. So you can read all this. But basically, I'll just tell you what the theorem says. It's called the conjugate root theorem, and it just says that, I guess I should just read it. All right. So if a polynomial that has rational coefficients, like regular numbers, like 2, 3, or even like 3/2, so rational coefficients, then irrational roots of this polynomial have a form of a plus the square root of b, and they occur in conjugate pairs. So that means that if a plus b is a root of the polynomial, then a minus, hold on, let me pause my video because it froze on me. Okay, so my document camera froze in the middle of the video, but I've restarted it and hopefully it's working now. I was trying to tell you about the conjugate root theorem that just says that if a plus the square root of b is a root of the polynomial, then its conjugate, which is a minus the square root of b, is also a root. So for example, here is example 5. Suppose that the quartic polynomial, so it's the quartic, so that means there are 4 roots, has rational coefficients. If the square root of 2 and 1 plus I are roots of the polynomial, what are the other 2 roots? So you would just use the conjugate root theorem and put the conjugate. So if the square root of 2 is a root, that means that negative square root of 2 is a root. If 1 plus I is a root, that means that 1 minus I is a root as well. And this conjugate root theorem only works when your roots are irrational, like the square root of 2 or 1 plus the square root of 3, or if they're imaginary. So it doesn't work if your roots are just real rational numbers. So I'll show you an example 6. Okay, so example 6. It says, write a polynomial function in factored form with rational coefficients so that the polynomial of x equals 0 has all of these roots. Okay, so for starters, 2 plus I is a root. So let me write it down. 2 plus I is a root. So that means that its conjugate, since this is an imaginary root, that means that the conjugate, which is 2 minus I, is also a root. So those are 2 roots for sure. Next, 1 minus the square root of 5 is a root. So let me write it down. So then, since this is another irrational root, that means that 1 plus the square root of 5 is a root. So again, only irrational roots like this or imaginary roots like that happen to fall into this conjugate root theorem. So if an imaginary root is a root, then the conjugate is also a root. If an irrational root is a root, then its conjugate is also a root. And next we have 3. 3 is a root, but that's not imaginary and that's not irrational, so just 3 is the root. That's it. And then finally, we have 0 as a root. Okay, so we need to write I guess a big polynomial that has 2, 3, 4, 5, 6, all of these 6 roots. So here's how you do it. There are 2 ways. Let's start with method 1. Okay, so one way to do it, which is not my favorite, but I have to show you anyway, is called using the sum and product of the roots. So let's call this method 1. Method 1. You can use what's called the sum and product of the roots. Okay. So this is not my favorite method, but I have to show you anyway, and then I'll show you my favorite method. All right, so the way this works is it only works for those conjugate roots. So I'm going to take these 2 roots only. So only works on conjugate roots. Conjugate roots. Okay, so here's what we're going to do. I wrote it here. It says, given that ax squared plus bx plus c is your polynomial, a, b, and c are integers, then, again, this is a quadratic polynomial here, so then the sum of the 2 roots is going to equal to negative b over a, and the product of the 2 roots is going to equal to c over a. So what that means is, let's just do it. Okay. Let's try to find the sum first. Sum of the 2 roots. So here are my 2 roots. 2 plus I and 2 minus I. So the sum of these 2 roots should equal to negative b over a. So let's go ahead and add them. Let's go ahead and add 2 plus I plus 2 minus I and simplify that so we can set it equal to negative b over a. So if I add 2 plus 2 is 4, I plus negative I is cancels, that equals to negative b over a. And therefore, I can make this 4 become a fraction by just putting it as 4 over 1. And now I know that a could equal to 1 and b could equal to negative 4, because I just have to divide by negative. So far, using these two roots, I'm going to come up with a quadratic that's going to be part of my polynomial. So now I need to find the c value of the quadratic. So again, these two roots are just going to give me one quadratic, which is going to be part of the polynomial, and then we'll keep doing it again. So let's go ahead and find c by doing the product of the roots equals to c over a. So here, product of roots equals to c over a. So again, you need to take your conjugate roots, so 2 plus I, and let's multiply it by 2 minus I. That's going to give you c over a. So let's FOIL this out. 2 times 2 is 4. The middle parts are going to cancel out because 2 times negative I will cancel with I times positive 2, so that cancels out. And now you multiply I times negative I. That will be a negative I squared. So that equals to c over a. And then if you remember imaginary numbers, an I squared is a negative 1. So this becomes 4 minus a negative 1. So that's just 5. Equals to c over a. Again, I can make 5 a fraction by putting it over 1. So we already know that a is 1, which I wrote over here. And now we know that c is 5. Okay, so then here's what this means. This means that my polynomial, part of my answer here is going to be, first let me just write the quadratic. So these two roots come from a quadratic. The quadratic that these two roots come from is, I'm just going to write it down, 1x squared, because remember it was ax squared plus bx plus c, plus bx, so minus 4x plus c. Alright, so this quadratic is going to be part of my final answer. So your polynomial is going to have a quadratic, which is going to take care of these two roots. Okay, now we need to find the rest of the polynomial. So we need to find another quadratic that's going to give you the other conjugate roots. So right here. So what we're going to do for that is, you can do the same thing I just did, I guess, if you like that method. So if you like the sum and the product, then go ahead and find the sum of 1 minus root 5 plus 1 plus root 5, and that's going to give you the a and the b. And then you can find the c value by doing the product. So you can multiply 1 minus root 5 times 1 plus root 5, and that's going to give you the c value. And you'll end up with a separate quadratic, which will also be part of your answer. That gives you these two roots. What I'm going to do is I'm going to show you the other method. So I don't really use the sum and the product of roots. I use something else, method 2. Okay, and it's called the Mr. Erickson because he taught it to me. So method 2, I'm going to go ahead and use it again. It only works for those conjugate roots, so I'm going to use the 1 minus root 5 and the 1 plus root 5. Okay, so since those are two conjugate roots, they come from a quadratic. And what you would do is you write your conjugate roots as one single thing by doing 1 plus or minus root 5, because that's what that is, 1 plus or minus root 5. And you set that equal to x. So step 1, set the roots equal to x. Step 1, set roots equal to x. So go ahead and take 1 plus or minus root 5 and set it equal to x. Okay, step 2 is you need to isolate the plus or minus term. So step 2, isolate plus or minus term. So in other words, I need to leave the plus or minus root 5 here by itself, and I need to move the 1 to the right. So I'm going to move this 1 to the right with a minus 1. So I have plus or minus root 5 equals x minus 1. So that's step 2. Isolate the plus or minus term. Done. Step 3 is going to be to square both sides and simplify. So let's put step 3 over here. Step 3, square both sides and simplify. Okay, so that means I need to square the left side of my equal sign, square the right side of my equal sign, and simplify. So here's what's going to happen with this plus minus when you square it. It's going to go away because a positive number squared is the same thing as it's positive, and then a negative number squared is also positive. So therefore here, plus or minus root 5, when you square that, that just becomes a regular 5. Regular positive 5. And that should equal to x minus 1 squared, so that's x squared minus 2x plus 1. So now simplify, and by simplify means I guess you want to set this equation equal to 0. So I guess set equation equal to 0. So let me move this 5 over to my right, and that would be x squared minus 2x minus 4. And this will be part of my final answer for example 6. So this quadratic here is that quadratic would give me the 1 minus root 5 and 1 plus root 5 roots. So now I'm almost done. To get my whole polynomial together, remember the whole polynomial was 6 roots, so it needs to be like 6 factors. Okay, so here's my final answer for number 6. I know which color to use. Okay, plus I can't even see the colors on here. That's fine. All right, so the final answer, you want to leave it in factored form. So that means that your polynomial is going to be, okay, let's start with our first quadratic. X squared minus 4x plus 5 times x squared, our other quadratic was x squared minus 2x minus 4. This is called factor form because you're just leaving it like that. If you expanded, this would be like a quartic, like x to the 4th. And let me wake up the computer because it slept again. There you go. And if you expanded, this would be a quartic, which has these 4 roots as its roots. But let's just leave it in factor form here. So this quadratic gives you the first 2 roots. The other quadratic gives you the other 2 roots. And to finish it off, the other roots are way easier. So if 3 is a root, that just means that x minus 3 is a factor, because you can just set like your 3 equal to x, I guess. So 3 equal to x, and set this equation equal to 0. So just kind of what I did earlier. So that means that x minus 3 is a factor. And finally, same thing. If 0 is a root, that just means that x is a factor. So now this whole thing is your final answer for number 6. So this polynomial here would give you the 6 roots that you started with, because that's x squared times an x squared times an x times an x. That's x to the 6th. And that is how you find the polynomial given the roots. Now that problem was kind of crazy. It was really complicated, but that's okay. Let's try another one that's a little bit easier. So let's do example 7. Same thing. We're going to do the same thing. So example 7 says write a polynomial, this time in expanded form. So we're going to multiply it out with rational coefficients so that p of x equals 0 has 6 plus I root 2 and 0 as roots. So again, according to the conjugate root theorem, since 6 plus I root 2, since that is a root, then its conjugate, 6 minus I root 2, is also a root, because those are imaginary or irrational numbers. And then finally 0 is a root. That's just 0. Okay, so example 7 only has 3 roots, so that means that our polynomial would just be a cubic. The way you would do it is the same way I did example 6. First, we're going to use the conjugate roots here, this conjugate pair. So these conjugate roots are 2 of them, so they're going to form a quadratic, or they come from a quadratic. So in order to find the quadratic, you're going to have to use either method 1, find the sum of the 2 roots, set it equal to negative b over a, and then find the product of the 2 roots and set it equal to c over a, so that you can find your ax squared plus bx plus c. And that would give you your quadratic. Or you use method 2, which is what I like, and that's what I'm going to do. So method 2 again. What you do with your roots is you set them equal to x. So let me write them down first as 6 plus or minus I root 2. Set that equal to x. So that's step 1. Set your roots equal to x. Step 2, isolate the plus or minus term. So move the 6 to the right with the minus 6. So plus or minus I root 2 equals x minus 6. Step 3, square both sides and simplify. So I'm going to square both sides. Okay, so this is going to be... Okay, the plus and the minus symbol will go away because when you square that, that just becomes a positive symbol. The I squared, when you square an I, that's a I squared, that's a negative 1. Square root of 2 squared, that just becomes a 2. So in other words, plus or minus I root 2 squared is just the number negative 2. X minus 6 squared would be x squared minus 12x plus 36. So now I need to simplify by setting the equation equal to 0. So move the negative 2 to the right. X squared minus 6x plus 38. All right, so this quadratic would give you the conjugate roots. So then for your final answer, or for your answer, so your entire polynomial will be the quadratic that we just found, x squared minus 6x plus 38. And then don't forget there was an extra 0 as a root, so that means that x was a factor. So again, this is called factored form, which is what we did on example 6. Factored form. And now this question was expanded form. So that just means you need to multiply it out. And this one's easy. You just multiply everything here by x. So x cubed minus 6x squared plus 38x. This is called expanded form. Which is what the problem wanted. So that just means that this cubic, x cubed minus 6x squared plus 38x, has the 3 roots that were given. And again, that is how you find a polynomial given the roots. So that's section 8.7. You're going to have to practice tonight. Please do your homework on 8.6 and 8.7 to help you practice this stuff. Good luck.